Today is 4-6, which now we are going to have inequalities that involve absolute value equations. So you have to remember what the absolute value is. An absolute value is a number's distance from 0. Because it is a distance from 0, you can never have an absolute value that is equal to a negative. So if we look at example 1 here, we have solved the absolute value, because remember our absolute value sign as your straight lines, plus 5 is equal to 11. So if I solve this, I'm going to minus 5 from both sides, so the absolute value of x is equal to 6. And then remember, there are two answers here, because the absolute value of 6 is 6, because 6 is 6 away from 0, and, oops, sorry, this should be x equals 6, or x can equal negative 6, because the absolute value of negative 6 is also 6. So we have two solutions here of x equals 6 or x equals negative 6. Remember, you could write it as x is equal to positive and negative 6. Either way is fine with me. On the second one here, the opposite of times 3 is to divide by 3, so we get the absolute value of n is equal to 5. Well, what numbers are 5 away from 0? The number 5 or the number negative 5. They're both 5 away from 0. So your answer there would be n equals 5, or n could equal negative 5. Example number 2 then, solving an absolute value equation with a variable inside. So now we have no numbers on the outside of the absolute value, so what we have to do is we're going to rewrite it. So we're going to say 2p plus 5 could equal 11. So what's inside of here could equal 11. But also, if I get what's inside is equal to negative 11, its absolute value would also be 11. Or, I'm going to rewrite it as 2p plus 5 could equal negative 11. And these are our two equations that are going to give us our two answers. So we have 2p is equal to 6, because we minus 5. We're going to divide both sides by 2, so we get p equals 3. Or, on the other side, when we minus 5, we get 2p equals negative 16. When we divide by 2, we get p equals negative 8. So our answer would be p is equal to 3, or p equals negative 8. If you wanted to check it, 2 times 3 is 6. 6 plus 5 is 11. The absolute value of 11 is 11. 2 times negative 8 is negative 16, plus 5 is negative 11. The absolute value of negative 11 is also 11. Example 3 then, very similar, except for now we have an inequality symbol. So anytime you have numbers within the absolute value, you have to write your two options. We have b minus 3, and you copy it down exactly like it is for the first one. Or the second one, we change the sign on that number, but if it's an inequality, you also have to flip the inequality symbol. So I rewrite it as b minus 3 is less than or equal to negative 4. So you flip the sign, and then you do the opposite. So it was positive 4, so now it's a negative 4. And now we solve our two equations. V is greater than or equal to 7, because we added 3 on both sides. Or, we're going to add 3 on both sides again. V is less than or equal to negative 1. So if we check our answers, 7 minus 3 is 4. The absolute value of 4 is equal to 4. Here, negative 1 minus 3 is negative 4. Negative 4 is equal. The absolute value of negative 4 is also 4. So both of those are correct. Remember, since these are inequalities, we have other options. For instance, 0 is less than negative 2 is less than negative 1. So I could put negative 2 in here. Negative 2 minus 3 is negative 5. The absolute value of negative 5 is 5. Is 5 greater than 4? Yes, so it does work. Example number 4 is our problem solving this set. It says the ideal diameter of a piston for one type of car engine is 90 millimeters. The actual diameter can vary from the ideal by at most 0.008 millimeters. Find the range of acceptable diameters for the piston. Well, we know our diameter at most can be 9. Or that's the ideal. the distance away from that can be at most, so it could be equal to, but no greater than, so less than 0.008. So my distance away from 90 has to be less than or equal to 0.008 in order for it to be an acceptable diameter. So now we solve it. Remember, if there's numbers inside of the absolute value, we write our two options. We have d minus 90, and we copy it exactly like it is without the absolute value symbols. Or the next one, everything in the absolute values stays the same. You flip the inequality sign, and you change the sign on our constant. To solve this, I would add 90, so d has to be less than or equal to 90.008, or d has to be greater than or equal to 89.992. So, if I look here, my answer is this. To write that solution out, I could say the following. The diameter must be between 89.992 and 90.008. Don't forget, this is inclusive because it could be equal to both of those as well. So my solution is the following. Let me put it somewhere you can read it. The diameter must be between 89.992 and 90.008 inclusive, which means it can include this number and this number exactly, or be between them. You need to complete the quick checks for this section and then look at your schedule to see what your assignment is that goes with it.